Hello everyone, we are Team LC. Here is our member list. So in this project, we have 7 functions to implement. And I'm going to introduce maximum circuit and minimum circuits together, and extract circuit and exclude circuits together, peak maximum circuit and peak minimum circuits together because they share similar algorithm. And this is the basic structure of our circuit. We use subtractor as our comparator. So in this part, we show how to find larger value between two numbers by subtraction, and we will use an index CMP to store which number is larger, and we use CMP and a multiplexer to decide which number should be stored into our temporary answer. And if we want to find smaller number by the similar structure, we can simply change A minus B into B minus A, then we can obtain the circuit we want. Next, for average circuit, since we could not produce any good idea, we now simply add the 8 numbers up and shift them 3 bits to the right. Now is for extract circuit and exclude circuit. We still use subtractor as our comparator. And in this place, we have 2 index, that is sign 1 and sign 2. If the sign index are set to be logic 1, then it means that it meets the condition, meets the criterion we set. And only when 2 criterions are satisfied at the same time, that is, the logic end between sign 1 and sign 2 equals to 1, then we output this number in that round. Otherwise, we won't output it. For peak maximum and peak minimum, we haven't come up with concrete Verilog code, so we now just introduce our thought. So in round 0, it would have its maximum value, and we store its maximum value into temporary answers. And in round 1, itself will have a maximum value. We call it max of 1. If max of 1 is greater than temporary answer, then we set temporary answer to max of 1, and we output max of 1 in round 1. Otherwise, we should output nothing in round 1. And you can notice that we have comparison here. I write it this way is for convenience. I will still use subtractor as our comparator here. So why we use subtractor in this 6th circuit instead of using comparator directly? It's because we need adder in average circuit. In order to reuse such structure, we decide to turn adder here to subtractor. That is like what we have done in homework 1. So it's for circuit reuse. So we use subtractor instead of using comparator directly. So here are some known and to be learned issues of the project. That is, we should maximize the efficiency and reduce the area. We should use similar structure to reuse the circuit, like what I've said on last page. And we should prevent flip-flop from being translated into latch while doing the logic synthesis. And how should we integrate our circuit to obtain maximize efficiency and lowest area. And here are our job distribution. And here is our schedule. We hope that we can finish the functions in week 4 and try to build all the circuit in week 4. Then we should use the test bench to check if our circuit is right or wrong. And then we should do logic synthesis and complete our final report in week 6. So here are some possible issues and our solutions. So like if we have flip-flop being translated into latch, then we should check our code and modify the code to make sure they are translated into flip-flop in logic synthesis. And here's one major problem that we don't know how to solve, but we will try to find a solution. That is, we don't know how to output nothing. For example, in peak maximum circuit, when like if our in round 1, the maximum value in round 1 is not greater than maximum value of round 0, then we should output nothing in round 1. However, we don't know how to implement such a function, so we will try to discuss with other group to obtain the solution. So that's all. Thank you for your listening.